In this video, we will practice finding the derivative of expressions involving inverse trig functions. Make sure you have memorized the derivatives of arcsine, arctangent, and arcsecant. The derivatives of arccosine, arccotangent, and arccosecant are the exact same things except with a -1 instead of a +1. In number 46, h of x is the product of two functions, so we have to do the product rule. When we do the product rule, we start by taking the derivative of the first function while leaving the second function alone. The derivative of x squared is 2x, and we leave the arctangent 5x alone. Then we put a plus, and we go through it again. The second time through, we leave the first function alone, so we will leave x squared. But we do take the derivative of the second function. Remember that the derivative of arctangent u is 1 over 1 plus u squared, except because of the chain rule, we have to multiply by u prime. In this case, u is 5x. So the derivative is 1 over 1 plus 5x squared. And then because of the chain rule, we have to multiply by the derivative of 5x, which is 5. On the next step, I'm going to put the 5 and the x squared in the numerator, and I'm going to go ahead and square 5x, so you will see 25x squared. So that's it for number 46. For number 50, we are going to take the derivative term by term. Remember that the derivative of natural log u is 1 over u, except because of the chain rule, we have to multiply by u prime. In this case, u is t squared plus 4. So the derivative of natural log u becomes 1 over t squared plus 4. But because of the chain rule, we need to multiply by the derivative of t squared plus 4, which is 2t. I'm going to put this right in the numerator. Next, we bring down the -1/2, and now it's time to take the derivative of arctangent t over 2. But we recall that the derivative of arctangent u is 1 over 1 plus u squared times u prime. So in this case, the u is the t over 2. So the derivative is going to be 1 over 1 plus t over 2 squared. But because of the chain rule, we have to multiply by the derivative of t over 2. I'm thinking of t over 2 as 1/2 t. So the derivative is simply 1/2. If this was a free response question on the test, you could leave your answer just like this. But let's go ahead and simplify this one, because what if you run into a question like this and it's a multiple choice question? I guarantee you the answer will not look like this. If you square t over 2, you get t squared over 4. Also, 1/2 times 1/2 is 1/4. Now we are going to take this 4 and distribute. 4 times 1 is 4, and when you multiply 4 times t squared over 4, the 4's cancel out and you are left with t squared. Of course, 4 plus t squared is the same thing as t squared plus 4. That gives us like denominators. So combining the two fractions into 1, we have 2t minus 1 over t squared plus 4. For number 54, we will take the derivative term by term. However, in the first term, we run into the product rule. We start by taking the derivative of x, which is 1, and we leave the second factor alone. Then we put a plus. The second time through, we leave the first factor alone, so that's x, and we multiply by the derivative of the second factor. The derivative of arctangent u is 1 over 1 plus u squared times u prime because of the chain rule. The derivative of 2x is 2, and I'm going to wind up putting this in the numerator in a moment. In fact, let's put the 2 and the x in the numerator right now. As long as we are making all of these cosmetic changes, let's go ahead and replace 2x squared with 4x squared. Moving on to the second term, we bring down the minus 1/4 And now we need to take the derivative of natural log 1 plus 4x squared. Well, the derivative of natural log u is 1 over u. So this will be 1 over 1 plus 4x squared. Because of the chain rule, we have to multiply by u prime. The derivative of 1 plus 4x squared is 8x. 4 goes into 8 twice. So on the next step, we will have a 2x in the numerator. But then we notice that the last two terms are like terms. In fact, the last two terms are opposites. They cancel each other out. So the final answer is just arctangent 2x. For number 58, we will take the derivative term by term. The derivative of arctangent u is 1 over u squared plus 1, except because of the chain rule, we have to multiply by u prime. I am thinking of u as 1/2 x, so the derivative is 1/2. I'm looking at this last term as negative 1/2 times x squared plus 4 to the negative 1 power. So we can take the derivative using the chain rule. First, we take the derivative of the outer function. So we do negative 1 times negative 1/2, and we get positive 1/2. The part on the inside stays the same, x squared plus 4, and we reduce this exponent by 1. So now we have the negative 2 power. But because of the chain rule, we then multiply by the derivative of the inside. So the derivative of x squared plus 4 is 2x. All that's left is to simplify. X over 2 squared is x squared over 4. Notice that we have a 2 in the denominator and a 2 in the numerator, so these are gone. Next, I will drop the x squared plus 4 to the negative 2 power down to the denominator because of the negative exponent. Notice that we still have a surviving x right here, which ends up in the numerator. I think I'm going to erase the 1 and replace it with 4 over 4, so we can have a like denominator going on in the denominator. So on the next step, I'm going to combine these into a single fraction, x squared plus 4 over 4. So now we have this. 1 over a fraction means the reciprocal of that fraction. Taking the reciprocal gives us this. Now I notice that we have a 2 in the denominator, which divides evenly into 4. So on the next step, we will have a 2 in the numerator. However, also, I'm noticing that I would really like to have a common denominator, and we are so close. We have x squared plus 4 and x squared plus 4. But on the right-hand side, it's x squared plus 4 squared. We have 2 factors of x squared plus 4. So I need to multiply the first term by x squared plus 4 over x squared plus 4, so we have a common denominator of x squared plus 4 squared. Remember, I divided the 2 into the 4, and that's where the 2 came from. And now I'm combining both terms into one big fraction with a common denominator of x squared plus 4 squared. So combining the numerators gives us this. Don't you dare try to cancel out the x squared plus 4 in the numerator with one of the x squared plus 4's in the denominator, because you can't cancel out something that is connected by addition or subtraction. That's bad algebra. However, I will distribute this 2 and combine like terms. Actually, there aren't any like terms, so this is the final simplified answer. For this last problem, we need to find an equation of a tangent line to this graph. Whenever they ask us to find the equation of a tangent line, we love to use point-slope form because it reminds us that all we need is a point and the slope. They already gave us the point, so all we need is the slope. And in a calculus class, we know that the slope is found from the derivative, which gives us the slope of a curve at a point. So let's find the derivative of arc secant 4x. Remember, the derivative of arc secant u is 1 over the absolute value of u times the square root of u squared minus 1. Well, times u prime because of the chain rule. In this case, u is 4x, so we get 1 over the absolute value of 4x times the square root of 4x squared minus 1 times u prime. The derivative of 4x is 4, and I'm just going to put that in the top. So this is the derivative of the original function. This expression will give us the slope of the curve at any point, including this one. So we just need to evaluate y prime at the x value of radical 2 over 4. Substituting radical 2 over 4 in for the x's of our derivative expression gives us this. Notice that these 4's cancel each other out. So on the next step we will have, well, I started to say the absolute value of radical 2, but radical 2 is already positive, so we will no longer need the absolute value symbols. Then we will have the square root of 2 squared. The square root and the 2 will cancel each other out, so that's just going to leave a 2. Don't forget about the minus 1, so we end up with 2 minus 1, which is 1. So the square root of 1 is 1. So this part of the expression will disappear. So we are left with 4 over radical 2. That's the slope. Now that we have a point and the slope, we can write the equation of the tangent line. The tangent line equation goes y minus y, meaning the y-coordinate right here, pi over 4, is equal to the slope, which is 4 over radical 2, times x minus x. And here's the x-coordinate, radical 2 over 4. You could get an answer that looks slightly different if you rationalize the denominator in the expression 4 over radical 2. If I multiply this by radical 2 over radical 2, I'm going to get 4 radical 2 over 2, which is 2 radical 2. So this could be the slope instead. So here's another version of your answer.